flange types. We're referring to the flange in its entirety, the design of the flange. Examples of flange types include the blind flange, socket weld flange, lap joint flange, slip-on flange, and threaded flange, also referred to as a screwed flange. These are flange types. The next important distinction is the flange face. So we had types, now we're talking about faces. A flange face is its sealing face. Common sealing faces are the flat face, raised face, and ring type joint. There are other types of sealing face available. It's just that the flat face, raised face, and ring type joint are the three most common sealing faces. So that's types, faces, and now we're going to talk about surfaces. A flange surface indicates the type of surface that is present on the flange face. So types, look at the flange in its entirety. Face, look at the sealing face. Surface, look at the surface on the sealing face. Think of it like this. If we look at flanges in their entirety, then we're talking about flange types. If we want to go into more detail, then we'll look at the design of seal used on that flange, and that is the flange sealing face. And then if we look again at the face in more detail, then we'll be looking at the flange surface. So big, medium, small, we're going into more and more detail. So let's now take a look at flange types. This is the blind type flange, or a blind flange. It's the simplest type of flange that you're likely to see. It's more or less just a slab of metal that's been cut into a circular shape, and it's got some holes in it which allows the studs or the bolts to pass through. If we take a look now at another type of flange, then we can take a look at the lap joint flange, which is also quite common, the slip-on flange, the socket weld flange, the weld neck flange, and the screwed or threaded flange. This is a threaded flange because we have a thread cut into the internal diameter of the flange. If we take a cross section, you can actually see that a bit more easily. And it's the threaded pipe end that would come in from the right and screw into the flange. The weld neck flange or welding neck flange is one of the most popular types of flange you're likely to encounter if you're working in the oil and gas industry or the petroleum industry, chemical engineering and industries like that. The welding neck flange is probably the most popular flange and the most common flange that you'll encounter. It's got a very distinct shape. The hub has this long neck, and we would connect a pipe to the flange using a butt weld. You can see that the flange has been prepared for the weld, which would go in this area. It's a very common type of flange because it's mechanically strong and it's suitable for a wide range of temperatures and pressures, although that depends a lot upon the type of face used, which we'll discuss in a moment. We've got a socket weld flange, which slide the pipe in, but only up to where this orange line is, because that allows us to weld the pipe, and we'll use a fillet weld for that. And because the pipe end will become hot, we don't want it expanding into the flange blade, so we leave a gap to allow for this thermal expansion. We then have a slip-on flange. The flange literally just slips onto a pipe, and once again we can use a fillet weld to attach the pipe to the flange. The lap joint flange is a more interesting type of flange because many people think that this whole item is the lap joint flange, but they'd actually be wrong. The middle item is actually a stub end, which is a type of pipe fitting. If you look, you can see that it comes in along here, and bends upwards, comes across, and it's not actually connected to the flange. It's a stub end. Around the stub end, but not physically connected to it, is the lap joint flange or the lap joint ring. So this entire middle piece can be slid out of the lap joint ring or the lap joint flange, or slid in, and that allows us just to slide it in and then connect it to the end of a pipe using a butt weld. Normally though, when people talk about lap joint flanges, they're including the stub end. But don't be thrown off by that, because if you're looking at literature, let's say piping standards, piping specifications, you'll need to realize that the stub end has a totally different pressure and temperature rating to the lap joint flange ring. And that's simply because the ring does not come into contact with the process fluid. Only the stub end does. And once again, we're back to our blind flange, and you can see that it has a very simple design. So we've covered flange types. Let's look at flange faces. We'll start with the most simple, and that is the flat face flange. The flat face flange has a large sealing area. It's actually everything between these two orange circles. Because we're using such a large sealing area, we'll only ever use soft gaskets with flat face flanges. Soft gaskets deform easily when applying small amounts of force. Why is this important? Because when you're in the field and you're tightening up the nuts of a flange, you'll need to obtain a certain sealing pressure. The larger the sealing face is, the more force you'll have to apply in order to get a certain sealing pressure. It isn't practical in the field to try and obtain a large sealing pressure with a flat face flange. This is because pressure equals force over area. Let's imagine for a moment that we have a very large area. I'm just going to do it without any units of measurement, so I'm going to call the area 100. We need to obtain a sealing pressure of 5. So we need to apply a force of 500. 500 over 100 gives us 5. If we want to increase the sealing pressure, maybe to 10, then we need to double the amount of force applied and take it up to 1000. Now that might be slightly impractical. There's only so much force that you can apply using a ratchet or a spanner. Obviously you can get hydraulic tools in, but you don't really want to be doing that. It's just not practical. So how are we going to achieve this higher sealing pressure? Well, using our equation, if we reduce the area, even if we maintain the force at what it was previously, which was 500, then we get a resultant increase in sealing pressure. So maintaining a force of 500, if we want to achieve a sealing pressure of 10, then we reduce the area to 50. This gives us 500 divided by 50, which gives us a sealing pressure of 10. So reducing the area allows us to increase the sealing pressure of the flange without needing hydraulics or very strong muscly men, or women for that matter. So we know that pressure equals force over area, and we know that regulating the area or adjusting the area allows us to also adjust the sealing pressure of a flange. Let's see that in action. Let's have a look at a different sealing face. We're going to take a look at a raised face flange. A raised face flange is much like a flat face flange with one difference. The sealing face has been reduced a lot. This area, highlighted in orange, represents the raised face. So we've lifted the sealing face off the bolting plane. The amount we actually lift the face off the bolting plane depends upon the pressure that the system will operate at. But let's forget about that for now. The big difference then between a raised face and a flat-faced flange is that the raised face is raised off the bolting plane and we have a much smaller sealing area. So before we go back to our flat-faced flange, the sealing area was between these two orange circles. Now, if we go to the raised face flange, the sealing area is between these two orange circles. It's much smaller. That allows us to use this type of flange sealing face for much higher pressures. So you can see now why pressure equals force over area is such an important concept. That simple equation answers a lot of questions concerning how flanges are designed. If we take a look now at our third and also very common type of flange sealing face, and that is the RTJ or ring type joint flange, the sealing face is actually only where this orange circle is. It is much smaller than the sealing face that we had for our raised face flange. Why is it much smaller? It's much smaller because we want to use the RTJ flange for higher sealing pressures. And all we're doing to achieve that is reducing the sealing face area in order to obtain a higher sealing pressure. So we talked about flange types, we talked about flange faces. Let's have a look now at flange surfaces, or to be specific, flange sealing face surfaces. I don't like to include face when I'm talking about surfaces because it kind of gets a little bit confusing, I think. So let's just keep it as flange surfaces, and let's pull up some examples. We'll go back to our flat face flange. This flat face flange has, remarkably, a flat face. But what does that mean? It means that the sealing face has no serrations, there are no indentations, and there are no tooling marks. If we go to the cross-sectional view, you can see the face is plain. Plain face, flat face, sometimes they're also called as FF flanges. These terms all mean the same thing. But we're not talking about faces, we're now talking about surfaces. So here we have a flat or plain surface because there are no tooling marks and no indentations, etc. If we look now at our raised face flange, you'll see again that we have this plain sealing surface, no tooling marks. Now I've switched to a welding neck flange and notice that our flange face is no longer plain, it's no longer flat. Why? Because we've got serrations. These are tool marks that have been cut into our flange face. If we take a cross section, it might be a bit easier to see. These particular serrations are very shallow, but you can still see that the serrations represent high and low points on the sealing face. The number of serrations, the geometry of the serrations, and the way that the serrations are cut onto the flange depends upon the design. The stock finish surface is the most common type of serrated surface that you're going to see. And you can see on this diagram that there are different types of stock finish depending upon the size of the pipe. A spiral serrated surface has a serration that's been cut in a spiral shape onto the flange sealing face. That's the serration shown on the right side of the screen. The big problem with this type of serrated surface is that thin, low viscosity fluids can flow along this serration path, the trough in the serration, from the inside outwards, and if that occurs, then we get a leak. Another type of serrated surface is the concentric serrated surface. Whereas before we had one continuous groove that made up a spiral shape, which formed our serration, now with the concentric serrated surface, we're using a series of serrations that have been cut into the sealing face in a circular shape, and these circular shaped serrations become gradually larger as we move from the inside diameter of the flange towards the outside diameter. And the final type of surface is the one that we looked at originally, the plain type, the flat type, also known as the smooth finish type. So just to recap, we've got a smooth or plain or flat surface. That is one type of surface. We've got a spiral serrated, also known as phonographic surface. That is another type of sealing surface. Then we have a concentric serrated surface, and that is the third type of sealing surface. The stock finish, which is the most popular type of serrated surface, is actually a spiral serrated surface. So a stock finish is not some special type of serrated surface. It actually just belongs to the spiral serrated or spiral serration family. So I hope you now know what a flange is. I hope you realise that it's a type of mechanical joint, that it's the second most popular type of joint after the welded joint. You should also know why we have flanges, so that we can obtain a seal. We discussed the different types of flanges, the welding neck flange, the socket weld flange, the lap joint flange, etc. We looked at some flange faces, such as the flat face flange, the raised face flange, and the ring type joint. And finally we looked at flange sealing surfaces, stock finish, spiral serrations, concentric serrations, smooth, plain, flat, finished surfaces. I hope you found this video informative and interesting.